Hi, my name is Mike Ball. I'm a front-end developer here at SIM. I'll be speaking today about Subversion and specifically SVN, which is Subversion's command line client. Subversion, if not everyone's aware, is generally the version control system of choice here at SIM, with the exception of, I believe, the mobile team who use Git. This is the tool we use to maintain and back up different versions of our source code. So throughout the presentation, I'm going to cover a little bit about Subversion background and history to get everyone on the same page. I'm going to discuss Subversion conventions and some SIM-specific Subversion conventions, basically how we use Subversion here at SIM. I'm going to address why you may want to use the SVN command line client. I'm going to cover a standard SVN workflow, some common operations in SVN, and I'll also speak a little bit about some helpful tricks and hints. So a little background and history on Subversion. Subversion is an open source project. It was founded in 2000, interestingly with the explicit goal of creating an improved alternative to CVS, CVS being concurrent version system. Subversion became an Apache Software Foundation project in 2010, and some popular alternatives to Subversion you may have heard of include Git and Mercurial, Git probably being the most stylish these days. So there are a few conventions at the core of Subversion's logic. So what's actually happening when we use Subversion? Subversion uses a copy, modify, merge model of version control. According to this model, users create local working copies, which are reflections of a central repository. We make changes and we merge our changes back to the code base, and problems and conflicts are resolved on the fly. This contrasts with a lock, modify, unlock model, which is the model upon which CVS was founded. According to a lock, modify, unlock model, only one user can change a file at any given time. The user locks the file she or he is editing and then unlocks it upon completion. Common criticism of the lock, modify, unlock model is that it's restrictive and slow. So in Subversion, revisions are tracked via .svn directories. These information in these directories tell Subversion which files contain unpublished changes, which files are out of date with respect to others' work, and also any previous changes made to the files in its directory. These .svn directories are found within each directory of a project, and committed revisions are assigned a number that corresponds to a snapshot of the code base at the time of its commit. So what does a typical Subversion repository layout look like? It's usually divided into three main directories: trunk, branches, and tags. Generally, trunk houses the bleeding edge version of the code base and is the main line of development. Branches are usually created as separate lines of development independent of other lines, and tags are essentially the same as branches but represent a snapshot of the code at some point in time. One point about tags is that you really shouldn't be editing code inside of Subversion tags, as once you start editing that code, it no longer represents an accurate snapshot of the code base at the time of its creation. So, Subversion at SIM. For the purposes of this discussion, I'll focus on XDS. XDS is the software on which Xfinity.com runs. XDS provides a pretty good example of a slight modification to a typical Subversion strategy. Our propagate script provides one noteworthy aspect of our unique Subversion strategy here at SIM. The propagate script is used by developers to merge change sets into other branches. Basically, it allows us to merge and commit with a single command. In a typical Subversion workflow, these tasks would consist of multiple commands. The propagate script also allows us to recycle our original commit message with each change set. So trunk in XDS. Trunk we usually treat like a bit of a melting pot of code. This is a bit unique in that typically trunk is much more stable than as we treat it here at SIM, and often released from. Branches in XDS. We create branches as separate lines of development independent of other lines. This is fairly conventional. For example, we have an MR branch that houses maintenance release code updates that are deployed to production outside of a sprint or before a sprint's completion. And then we have quite a few branches tied to a specific sprint. Tags in XDS. Tags are where we store snapshots of our releases. And again, we shouldn't edit the code in tags. So here's what that layout looks like. I'll note that some of our projects here at SIM are much more complicated and larger than this, but XDS provides a pretty simple example for the sake of this discussion. So moving on to SVN. As I explained, SVN is the command line client for Subversion, and this is what most of my presentation will focus on. First, why would you want to use the command line client to manage Subversion? The command line client is often regarded as cumbersome and awkward, so why would you choose this over a GUI Subversion implementation? Well, you might not want to, and that's fine, but I still think it's useful to know. So what exactly is so useful about SVN? Well, for one, I often hear complaints about Aptana and Eclipse or different IDEs used by developers, and I would argue that a knowledge of Subversion, or excuse me, SVN specifically, could empower developers to experiment with other tools and editors. Not that there's necessarily anything wrong with these IDEs or any sort of GUI Subversion implementation, but I would argue that there's some value in experimentation. And additionally, I'd also argue that SVN is a great and powerful and elegant tool once you feel comfortable with it. It does its job very effectively with very little feature bloat. So hopefully this won't feel like I'm reading you a cheat sheet, but I'd like to walk through a few examples. So first we're going to walk through a basic workflow example. This example assumes no problems and that there's no need to include a special commit message. We begin by CDing into the directory on our machine to which we'd like to check out a working copy, which we'll do with SVN checkout and specifying the path to the central repository. Locally, we'll edit files and make changes to our working copy. We'll make sure our working copy is up to date before proceeding with SVN update. We'll view the status of our working copy with SVN status, and we'll commit our changes with SVN commit. And then, of course, here at SIM, we'll propagate or merge our changes to other branches or trunk using the propagate script. I'd also like to note that many of these commands can be abbreviated. So, for example, SVN checkout can be abbreviated to SVN CO. But for the scope of this presentation, I really won't be using any of the abbreviated versions of the commands. So beyond this basic workflow, let's move on to some more realistic and problematic examples. First, here at SIM, we need to include a message alongside our commits. This can be done in a number of ways. First, we'll have to specify an editor. SVN stores your info, your user info, in a .subversion directory, which is usually found in your home directory. And in this directory, there is a config file. In this file, you can specify a text editor to be used with SVN. So in my example, I've specified VI. So once you've specified an editor, you can commit a message with, you can commit with a message by running svn commit-m. This will open a file in your specified editor inside of which you can write your commit message, save and close it, and then that commit message will be saved alongside your change set. Alternatively, you can do the same thing directly from the terminal with one line of code, svn commit-m, and then specifying your commit message inside of quotes. But what about the standard sim commit message format?